Hello, my name is Nate Burleson. I'm a member of Group 8, and our presentation this week is going over our Update 3 for our Bitcoin Tweet Sentiment Analysis project. So last time we talked about how we pre-processed over 3 million tweets, so we removed things like stop words, special characters, we applied limitization to the text as well, and then we also analyzed different characteristics of our data, things like the number of stop words in a tweet, um, the number of like positive words, the number of negative words, and then we also ran multiple sentiment models. We ran Fader, CentiWordNet, which is a part of the NLTK library in Python, the positive and negative word count one, text blob, and AFIN. So these sentiment models gave us a score for each tweet, and that score was decided based on a majority vote from those five outputs, and we ended up with a -1 for a tweet if it was considered a negative sentiment, a 0 if it was considered a neutral sentiment, and a 1 if it was considered a positive sentiment tweet. So for this time, we're going to show you visualizations that we worked on, and Vatzel is going to go over the bidirectional LSTM algorithm model that you went over. So first, the visualization. Here's the visualization showing the frequency of words. It's a very simple plot just made in Python. So you can see the project is one of the most popular words. And it's important to know that these are the words that show up the most frequently after we have removed the stop words. So the next visualization I'm actually going to show you will have the stop words and which stop words showed up the most. But after that was removed, you see things like project, blockchain, buy are important words that show up in a lot of different tweets. So you have different things kind of going over the financial side of things, different terminology like that, like buy, market, USD, trading. But then you have more things that have to do with cryptocurrency itself, like NFTs, altcoin, Doge, XRP, which are all different types of things, as well as just some other crypto and random words in here. So the next visualization, as I was saying, is the stop words. So these are the words that show up commonly, and in working with text data, it's good to know that. My apologies. It's good to know that what words will actually show up a lot and how we remove those. So these are words that will show up in all sorts of text a lot, but as you see I, me, my, because these are tweets, so it's all coming from someone. It's all coming from someone's perspective for the most part. And then here's the word cloud for the tweets. This is just a better way to kind of see how everything kind of shows up. Update, altcoin, follow, recent, update. Like sometimes with this, the words will show up 2 different times, but it all has to do with different levels of frequency. And so the next thing will be Vatzel going over his part of the model.
Hello. So we have used bidirectional LSTM over here to classify the sentiment of tweets. I used tokenization first on input text to create sequences of integer and then padded each sequence to the same length. The input text here is the tweet. And then I used train test split and defined multiple hyperparameters like learning rate, decay rate, epoch, etc. Then in our neural network, we have multiple layers that we can see on the right side through the image. We use input layer and convolution layer at the beginning and use pooling to decrease the size before applying it to LSTM. LSTM has an output size of 64, so we had to use dropout layer to avoid overfitting. Then at the end, we use softmax function to normalize the output. We can see here that the model reached 92% accuracy in training, validation, and test. And there is no amount of overfitting at all. And all the other metrics like precision, recall, and F1 score, those are also very high. With each epoch, the model learned and stopped overfitting. That we can see when it's learning, and that we can see much better over here through the visualization. So we did not use any hyperparameter tuning here, as the accuracy was already too high, and we doubted that it would increase overfitting. Next, we have a confusion matrix for the model. We see here that the model is classifying many tweets as neutral and is struggling to classify those tweets as positive or negative. But that's because most tweets are labeled neutral by a sentiment analysis when we applied a few models at the beginning. So we might require some more preprocessing to change that. But overall, the results are very promising. Next, we have planned to use some more classification models like BERT, and if possible, use this dataset to predict price of Bitcoin also. We saw some papers related to it, so we might do that. Also, we are planning to add more visualizations to so we can analyze the result much better. That's it. Thank you very much.